Okay, up next we're looking at types of discontinuities and what this means. So in this video we're going to cover what the types are, and next video we're going to look at what continuity means in general and what were in math terms and how to plug them in, how to fix them. So the first discontinuity we have is called a hole. The second is an infinite discontinuity or a asymptote discontinuity, and the third is a jump discontinuity. What you have to know about these is that the hole discontinuity is removable. The infinite discontinuity or the asymptote discontinuity is non-removable, and so is the jump discontinuity. So these two down here, non-removable, top one is removable. But what are these different types? So the first one, the hole discontinuity, is when your graph just has a hole in it, right? It has one point that just does not exist. That's an open circle in it. That one's pretty simple. It's like the most straightforward. Infinite or an asymptote discontinuity looks like this. It's when there's an asymptote that goes on forever infinitely, either up or down, doesn't matter. They don't have to agree with each other, but if there's an asymptote that's stopping the two lines from ever touching, that's called an infinite discontinuity or asymptote discontinuity. A jump discontinuity is when your graph just has a jump in it. So for example, if you look at this graph down here, you have two lines and there's just a gap in between the two if there's a jump. So if you look at all of these, you can see what discontinuity is. It's just any time that your line is like interrupted or it doesn't go all the way through. Like this, if you're drawing this line, you have to stop at this point and then continue over here. You can't just continue all the way through. So there's a discontinuity at this point. These ones, obviously, they're not connected with the asymptote, so these all have discontinuities. Yeah, so discontinuity is when the line on the graph doesn't connect all the way forever, right? Or if it's continuous over a certain time period, the line has to connect over that certain time period. So now I have two examples of two different non-continuous graphs, and we're going to find what the discontinuities are. We're going to go through how to find it on the first one, and you guys should try it on the second one. So anytime the denominator of a function equals 0, your graph is not going to be continuous, right? Because you can't divide anything by 0. Since you can't divide anything by 0, anytime the denominator is equal to 0, the point on the graph is not going to exist. So your graph is not going to be continuous. It's either going to be a hole, it's going to be asymptote, and we're going to go through right now how to find which switch. So if you have a graph like this, first thing you do is you need to factor it to see what the bottom can't equal. So we'll factor the top first, and you'll have x plus 4 and x minus 2. And if you factor the bottom, you get x plus 4 and x plus 6. So if we look at these 2 points on the bottom, we have to see what could make these equal 0, right? So the first one, if we have x plus 4, and we try to get that to equal 0, x has to equal negative 4. And the second one, x plus 6 equals 0, we'd have to get negative 6, right? So your 2 points of discontinuity are going to be x equals negative 4 and x equals negative 6. The reason why this works is because if either of these are equal to 0, it's just 0 times something. So if one of these is equal to 0, the whole denominator equals 0. So to find which type of discontinuity each of these is, you're going to look, and anything that you could cross out and cancel is going to be a hole, and anything that you can't is going to be an asymptote on the denominator. So if you look at this, x plus 4 is on the top and the bottom. We can cancel this out. So we know that x equals negative 4 is going to be a hole. X equals negative 6, you're not canceling it, it's just staying here. So this is going to be an asymptote or an infinite discontinuity. And if you guys want to try to solve the right one on your own, I'll give you a second right now, and we'll go over it. So go ahead and pause the video, whatever. 3, 2, 1, we going. So we're trying to solve this over here, and we're setting the denominator equal to 0. You can't factor the top, we'll keep the top the same, x plus 1, over, if you factor the bottom here, you'll get x plus 1, 3x plus 4, I believe. Yeah. So if we set each of these equal to 0, you'll get x equals negative 1, and for the right, x equals negative 4 over 3. Don't know how we got that. You have 3x plus 4 equals 0. You want to move the 4 over, so you have 3x equals negative 4. So then x equals negative 4 over 3 because you're dividing both sides by 3. Okay, so these are your 2 points of discontinuity. And the x plus 1 is going to cancel right here, so this is going to be a hole. And this side, you're not canceling anything, so this is just going to be an asymptote discontinuity or infinite discontinuity. That's it for this section. Pretty simple. I think we did a lot of this in pre-calc, so we're going to move on.